Hey everyone, it's Miss Mac here with another short video, this time reviewing linear inequalities. We have two learning objectives for today. Our first learning objective is that we can graph a linear inequality, and our second objective for today is that we can write a linear inequality from a graph. So first, let's review what is a linear inequality. A linear inequality is an inequality involving a linear function. And if that sounded like a little bit of a circular definition, let's look at some examples here. So a linear function is a function that creates a straight line. And a linear inequality is really similar to a linear function in that part of this graph will look like a straight line, and the other part of this graph is going to have a shaded region that talks about all of the solutions of that linear inequality. So when a linear inequality is graphed, it shows us all of the parts of the coordinate plane that make that inequality true. And we call all of these points that make the inequality true solutions. So if you look at the graph on the right, everything that falls into that orange shaded region is a solution to this inequality, because if I were to pick any of those points and plug in my x and my y value into this inequality, y is less than or equal to x plus 2, any one of those points in the shaded region would give me a true inequality statement. Or in other words, both sides of the inequality statement would be true. So our first learning target is to be able to graph a linear inequality, and here are the steps that we will use to do that. First, we'll make sure that our linear inequality is in slope-intercept form, which is the format that we've been using to graph linear equations. Next, we will use our y-intercept and our slope to graph a sketch of our linear inequality. And third, we will choose what type of line and what type of shading to use based on the type of inequality symbol that we have. So really quickly, let's review when we use different types of lines and when we use different types of shading. So if I use a dashed line in an inequality statement, that must mean that I had a less than or greater than sign. And if I use a solid line, that means that I have a less than or equal to or greater than or equal to sign. So the difference here is whether or not there is a line underneath the inequality statement. And if there is a line underneath the inequality symbol, then that means I will use a solid line in my graph. The next question we need to answer is, where do we shade on this graph? And that also depends on what type of inequality symbol we have in the problem. We shade above if the inequality symbol is greater than or equal to. We shade below if the inequality symbol is less than or equal to. So let's look at an example together. The first step we need to do is decide if this is in slope-intercept form, and it is. Next, we'll use the y-intercept, which is -2, and we'll use the slope to create a sketch of our graph. So from our y-intercept, we can go up 2 units and to the right 1, or we can go down 2 units and to the left 1 in order to create our graph. Next, we need to look at our inequality symbol, and I noticed that the inequality symbol that we have here does not have a line underneath the symbol. So that means that when I choose my line, it should be a dotted line. And the final thing I need to decide is what type of shading I will do to this graph. I notice that the inequality symbol that I have here says less than. And every time I see a less than, I know that means I'm going to shade below my line. So here's our final graph. Y is less than 2x minus 2. Our second learning target is to be able to write a linear inequality from a graph. So our first step in doing this will be to identify the y-intercept. Next, we will find the slope. And finally, we will determine what inequality symbol to use based on the type of line and shading that we have on the graph. So basically, we're doing what we did in the previous example in reverse. So let's look at this example here. My y-intercept is at +1. So I will say b, my y-intercept is equal to 1. Next, I need to find the slope, which means I need to pick 2 points that lie at corners and figure out how did I move from between these 2 points in order to go from left to right. So to go from left to right, I went down 1 unit, and to the right 2 units. So my rise is -1 and my run is 2. Next, I'm going to look at the shading on this graph, and I notice that I shaded everything above this line. I also notice that this line is a solid line. So that tells me two things. It tells me that I have a greater than symbol, but also that there is a line underneath that greater than symbol to mean greater than or equal to. So my final inequality is y is greater than or equal to -1/2 x plus 1. Sometimes we have some special cases where we write linear inequalities that only have one variable. And this is when we have horizontal or vertical lines. So if we notice that we have a horizontal line, this means that we only use the variable y. Just like in the example that I have here, we have y is less than -4, which means we used a dotted line and we shaded below, but we did a horizontal line where y is equal to -4. And a vertical line means that we only use the variable x. So in this example we have here, we have x is greater than or equal to 5. And we have a vertical line that is solid because we have a line underneath our inequality symbol. And we're shading this time everything to the right because to the right, all of my x values are getting greater. All right, everyone, if you still have questions, go ahead and watch this video one more time. And if you're really struggling, shoot Miss Mac an email. Don't forget to like this video. And of course, if you haven't already subscribed to our YouTube channel, please go ahead and hit the subscribe button. Thanks for watching.